everyone, welcome back to this AMC series. My name is Angelina Quan and today we'll start with counting. So for the last few videos we did number theory and we'll skip around a little bit. So after number theory it's counting, and then we do some algebra, geometry, and then we go back to number theory so that we could get a little bit of everything and see what fits you and what doesn't really vibe with you. And sorry, it's kind of windy out here. I'm recording outside, so I'll just try my best to coordinate everything. So counting. For counting, I don't mean count your fingers 1, 2, 3, 4 counting, but more complex countings that require strategies and just basic theorem knowledge. So I will start with a few simple examples to get you started, and I'm sure you've probably known this from one source or another, but I'll still go ahead and start. So first, it's a really simple question. You have 3 letters, A, B, C, and you're trying to arrange it to create a word. So even if the word is like B, A, C, it works. Just any word with the 3 letters A, B, C, and it doesn't have to be a legit word. So this is the first thing we're gonna do with counting, and it actually has a name, which is combinatorics. So if you think about this, we're trying to put 3 letters on 3 lines. So let's consider it just each line on its own. So let's see this line. How many choices does it have? Oh, one more thing. So for A, B, C, we don't want it to repeat. So if there's A here, we don't want A here. Like we don't want A to appear in a word twice. So let's go ahead and get started. And we'll consider the other case just a few minutes later. So if we want to see how many choices do we have for this, we know we have 3 choices, A, B, and C. So that gives us 3 choices. And then now we go to the second line here. But here, something we have to consider is that we cannot use A anymore. It's either B or C. So now we have 2 choices. And then we go to the third line. And now we don't even have B anymore. Let's say we choose B. Or whatever letter we choose, we just lose one more option, right? So now we have 1 choice. And now we're trying to figure out how many words that we're trying to obtain from the letters A, B, and C without repeat. So any repetition of letter is not allowed. So this becomes that simpler problem because we're trying to count. So for this one, we have 3 choices. But now we only have a 1-letter word. So we're trying to get a 3-letter word. So we slowly construct it. So we want a 2-letter word now. We have 2 choices. And a 3-letter word, 1 choice. But the question is, the $1 million question is, do you add them or do you multiply them? Might be a little bit hard to actually show you with abstract knowledge. So I'll just go ahead and show you which way we're supposed to do. So for example, let's say for the first letter we choose A. And for the second letter, now we have B or C. Let's say we choose B. And then the third letter must be C, or A, C, B. And that's all we get if we use A as the first letter. But now we go to the second choice for the first letter, B. So now we can choose BAC, BCA. So as you can see, you're slowly grasping this pattern of having 2 choices after you've determined the first letter. And that is because once you settle with your first choice, this becomes a 2-letter problem. So you're trying to find out how many choices of letters can we get from 2 letters to a 2-letter problem. So 2 underscores. So now you kind of see this pattern forming. And I'll do one more example and see if you can get this on your own. If we settle down the first letter with C, we get C-A-B or C-B-A. Do you see a pattern here? I hope so. But if you don't, you see, what is happening over here is that once you choose the first letter, you have two more choices for this and one more choices for this, but you have three choices for this. So for each choice of the first letter, you get two more choices of the second letter and one more choice of the third letter. So if we have three choices for the first letter, we have two choices for the second letter and one choice for the third letter. So that gives us 6 choices to construct this word. Super cool, right? Now we'll generalize it a little bit, make it a little bit harder, make it a little bit more fun. So let's say we have 3 underscores to construct a 3-letter word again. And we still have A, B, and C. And this is where I didn't get to last time. If we want to construct a 3-letter word with repetition, so even if A's here, A can still be here. That seems a lot harder, right? But it's actually not, because what we could do to simplify is think back to our last problem. What did we really do? Well, we just basically made it a little bit simpler by considering it each letter of the 3-letter word. So first letter, 3 choices, second letter, 2 choices, third, like that. So we could do the same thing for this question. So first, the first letter, we know we have 3 choices. Second, that's still 3 because we can have repetition. And the third letter, still 3 choices. So that gives us 3 to the third, which is 27. So you see, the problem here is that once you understand how this thing works, so basically you want a 3-letter. So basically you just want to make sure that for each choice, you're considering other choices equally. So once you have 3-letter choices for the first one, the n-letter choices for the first one, you have n-letter choices for the second one, and then you can do combinations. So for each choice of the first letter, AI, you have B1, B2, which is the choices for the second letter, B3, B4 to BN. But then for AI plus 1, you have the same exact thing. So as every kid in elementary school would know, that's multiplication in simpler terms. So that's it. That's all I have for this lesson, and I'll continue with more counting strategies and more counting, understanding the theory behind it in the next lesson. Thank you. Bye.